This video covers packet tracer 1776. Let's get started. This packet tracer is to troubleshoot connectivity issues and fix them where we can, and also to document them. In this scenario, users are reporting that they can't access the web server here on the other side of the cloud, www.cisco.pka, after a recent upgrade that was done on that web server that included adding a second domain name service, or DNS server for short. You must find out what's causing the problem and attempt to fix the issues for these users back here on this side of the cloud. Clearly document the issues and any solutions. You do not have access to the devices in the cloud, and this is where router R2 is here in the internet cloud, if you see any references to router R2. And you do not have access to the DNS server that's being managed by a different organization. So you may have to escalate any problems if necessary. And by escalate, that just means contact someone to get the problem fixed. Another note here is that router R1, which is our edge router on our network here, where we have this LAN and this LAN, that router can only be accessed using Secure Shell, or SSH for short, with username admin01 and password Cisco12345. So if you were to click on R1 and attempt to click on this CLI, you would get blocked there. Only accessible coming in through the VTY line through SSH. And as mentioned, router R2 is in the ISP cloud and not accessible. In part one, we are going to look at a connectivity issue from PC01. Open a command prompt, enter the command ipconfig, verify what IP address and default gateway have been assigned to PC01, correct as necessary. Looking at the addressing table for PC01, network interface card should be configured with IP address 172.16.1.3 with a 24-bit mask as shown here, and a default gateway of 172.16.1.1. Right away, there looks like there's a problem where that is 168 in the second octet there instead of 16, which would be a completely different network. The mask itself does look correct, as does the default gateway. We have to correct that as necessary to match our documentation by going to the IP configuration tab. And that's pretty easy to correct. Just change that from 168 to 16 there. Looking at the document, part 1A is done. That correction has been made. Then it's time to validate the condition of the network by using ICMP echoes, aka pings, starting with the default gateway. On PC01, go back to the command prompt. The default gateway for PC1 is 172.16.1.1 as per the IP config information above. And right away that is successful, so the answer here would be a yes. Just moving down the line through these steps, can you ping the web server, which is 209, and you can copy and paste out of the table if you prefer rather than typing. 201.2, it's ARPing. And once that ARP was successful, the ARP table was populated with the IP address not of that remote network address, but of the default gateway on the local subnet, which is router R1's interface right here. So that looks good. So that would also be a yes. The next question is, can you ping PC02, which according to our table is 172.16.1.4, which is right on the same subnet. The router doesn't come into play. PC2 and PC1 are connected to the same layer 2 switch. That ping would traverse this path right here. There's no need for the router to get involved. That's only if they're going to ping another network. So that would be a yes. That was successful for PC2. The next question, can PC01 ping PCA, which is on a different network and will therefore require a router to do some routing. PCA is 172.16.2.3, so this will be a no for PCA. 209.165.200.225, which we can see by looking at our address table, belongs to R2, which is over here in the cloud, sent this message back saying destination host unreachable. So does not know the route to get to that IP address. Interesting that would come from here in the cloud rather than from R1, who is actually connecting those two networks, but you'll see why it came from here a little bit later in the process. The next ping that you're asked to do is to PCB, which is on the same network as PCA, so you can predict they're going to be the same because those two endpoints are in the same LAN. And if one's not reachable, quite possible the other one won't be as well. So that takes care of step B. Moving on to step C, to use the web browser, going out of this to access the web server, first by using its URL, which is www.cisco.pka. Click go, or you can press enter. Yes, that is successful. This is domain name service, or DNS, in action. Routers don't do domain names. A router can't route www.cisco.pka. That's where DNS comes in. It resolves or does resolution of this to an IP address and then sends that on to the router. So DNS made it possible for this to be displayed. So you've got a yes, first of all, to answer the first question under C. The second question under C is where you're going to use that IP address and you're going to bypass DNS. You don't need DNS if you are using the actual IP address that's already done. And that also works successfully. In step D, document the issues that you've run into so far along with the solutions. The correction has already been done, right? So far, think about our issues we've had so far. The IP address on PC01 was incorrectly configured. That's an issue. The solution is changed it from 172.168.1.3 to 172.16. Also, you found that PC1 cannot successfully ping the PCs on over here, the 172.16.2.0 network. So that is also an issue you should list. And we will continue working to fix that second issue. So in part 2, open up a window on PC2 desktop. Open a command prompt. Again, run the ipconfig command. We have an IP4 address of 172.16.1.4 for PC02. That looks good. We have a 24-bit mask. That also looks good. And our default gateway is configured as 172.16.1.11, which does not match what's in the table. And by the way, if you tried to ping 172.16.1.11, no response because no device has been configured with that IP address on this network, which means that PC02 would be isolated from reaching remote networks, but would be able to still talk to PC1. Correct as necessary over from here to the IP configuration and just simply correct that to 172.16.1.1, which is the correct address for this interface off of R1 that is the default gateway for this LAN that includes these devices here. Moving on to B, we're going to walk through the pings to the various devices, starting with PC2's default gateway, which it should be able to ping now. The correction allowed this default gateway to communicate now with PC02. The next question is, can PC2 ping the web server IP address 209.165.201.2? Yes, that is successful. So far we've got 2 yeses. Can PC2 ping PC1, whose IP address is 172.16.1.3, since they're on the same LAN? That's a yes. Let's try PCA over on the 172.16.2 network, 2.3. This is the same response that PC1 got coming from router R2 in the cloud. There is a routing problem. That destination host is unreachable. So that's a no. And PCB will probably also be a no. That's 2.4. Okay, same error. So that's two no's in a row there. Now let's look at our ability to get to the web server. First, using DNS to resolve www.cisco.pka. Okay, that was successful. And then to do it by the IP address, which DNS would have resolved that too. So we've taken out the middleman and just doing that directly. And that is successful as well. So at this point in the document, then, you would be on part 2D, where you're asked to document the issues that you found in this section and whatever solutions. So we found that PC2 had an incorrect default gateway that needed to be configured and corrected to be 172.16.1.1 on PC2. Once that was corrected, PC2 could access the web server. However, PC2 cannot successfully reach the PCs on the 172.16.2.0 network. So in part 3, open PCA command prompt ipconfig to double check the local information. PCA should have an IP address of 172.16.2.3, a 24-bit mask, and a default gateway of 172.16.2.1. So there are no errors on PCA so far to correct. We did not need to correct any IP addressing issue on PCA, so ignore that. It's time to do some pings. So on PCA, the web server is 209.165.201.2. Will we be able to get an echo reply back from our echo request? We're getting a request timeout here. Let's check the ARP table. So what should have happened here is when PCA attempted to reach this remote host, it would have sent out an ARP request. And what should have happened is R1, the default gateway for PCA, which is correctly configured on the PCA side, should have replied to that ARP request with its own MAC address as kind of the doorway out to get to any remote networks. The fact that that didn't happen and that there's no ARP entry in here is a really good clue that there is a problem with the default gateway here. So there's a no for the web server. Another good way to check is, can you even ping the default gateway? Again, that is timing out. There is no success here. I'm just going to Control-C out of that and check my ARP table again. So that's a definite no, that it can't ping the default gateway. Can it ping PCB, which is on the same LAN and therefore doesn't require a default gateway to get involved? So you could predict that's probably going to be successful, which it is, because that's all happening just here locally without even leaving this layer 2 switch. And if you look at the ARP table now, what happened, you were successful in getting that ARP, which was answered by PCB. So everything's good, PCA and PCB being able to talk to each other. Can they ping PC01? You could predict not, right? Because that's on a distant network. That requires a default gateway to be up and functioning. That's eventually going to time out. No new ARP entries. And you can expect the same to happen with PC02 because that's on the same remote LAN as PC01. But we're getting closer to figuring out the problem here with this situation. It's pointing to R1. We're still going to do a couple tests before we get to R1, which is look at our web browser. And the first question is, can PCA access www.cisco.pka? We can predict based on everything else we've seen that that is not going to work. And you can use the fast forward button to fast forward things. And that gave us this error message, hostname unresolved. So looks like there may also be a DNS issue going on in addition to an IP routing issue. Can we use the IP address itself and bypass DNS successfully? And you, again, can fast forward because sometimes these two things take time. In this case, we got a request timeout, which is similar to what we saw with our echo replies not coming in from our echo requests. Before we document our issues and provide the solutions, let's see if we can correct the issue that we believe is a problem on R1. As told in the beginning, the R1 is not going to allow us to use the CLI, so we will have to SSH in on the V2I lines. It would make sense that if PCA and PCB cannot ping that interface there, they're not going to be able to successfully SSH in either. So we will have to choose an endpoint that we know has reachability to R1. And we know from earlier that PC1 and PC2 can both ping this interface, their default gateway on R1. Pick either one of those, go to the command prompt. So the command is going to be SSH -L for login, and then the name of the user that you're logging in as, which is admin01 as shown in the instructions, and then the IP address that you're SSHing to, 172.16.1.1. The password we were given is Cisco 12345. Now we are on the command line of R1 and able to do some troubleshooting. Show IP interface brief to see what's going on here. The interface that is the default gateway for this second LAN is this one right here, which is G0/1. And according to our table, that should be addressed 172.16.2.1. But it's actually addressed as 172.16.3.1, which is a completely separate network. So that would definitely prevent R1 from being a working default gateway for the endpoints that use it as a default gateway. So these guys are basically isolated because they don't have a working default gateway. When we were looking at that earlier, why was it coming from R2 over here saying that there was a problem? Well, that's because if you do a show IP route on R1, it doesn't have the route 172.16.2 in its routing table. So anything that's trying to reach 172.16.2. anything, which these were earlier, router R1 doesn't have a route for that network in its routing table because of that addressing problem. So what it's going to do is if it has a default gateway configured, it will forward those packets to that default gateway and hope that that default gateway router has a route to 172.16.2 network in this case. So that gateway of last resort is configured as the serial 000 interface, which is this 209.165. This is the default gateway interface. So any packets that it doesn't have a route for, it forwarded out to the cloud, which hit R2. R2 doesn't have a route to 172.16.2 in its routing table, which is why R2 sent the response back to these endpoints saying destination host unreachable because R2 had no route to that network. We do need to fix this on R1 by going into config mode, conf t, making sure we do choose the correct interface, G0/1 for short. We want to use the IP address command to set the address to 172.16.2.1. The mask is going to be 255.255.255.0. Once that's done, the percentage here is going to go to 100% on the PKA file in case you want to go ahead and save that. And now looking at show IP interface brief and show IP route, there is now a route in the table for that network, so the default gateway or gateway of last resort is not going to come into play anymore or need to because R1 is now correctly configured. In your document for part 3D, document the issues and provide the solutions. The issue was G01 on router R1 was configured incorrectly as 172.16.3.1 and was not functioning as default gateway, so PCA could only access the local LAN. By going into router R1 and changing that to 172.16.2.1, that corrected that issue. Moving on to part 4 to see if there's any issues from PCB's perspective. We again go to our ipconfig command to check any possible discrepancies. 172.16.2.4, the mask and the default gateway are all correct. So there are no IP addressing issues to correct, so ignore that and start doing some pings. Can it ping the web server 209.165.201.2? Yes, that is successful. Can it ping its default gateway 172.16.2.1? Now that that's repaired, we can guarantee that that's going to work a lot better, which it does. Next, can we ping PCA, which is PCA is 172.16.2.3. That is successful. Can we ping PC01? 172.16.1.3. That's much better. That's all working. And then we can guess that 1.4 is going to work, 1.4 as well, since they're on the same network. So far, so good. That takes us to part 4C. Look at our web browser since we got all yeses on our pings. We've corrected some problems and are seeing much better conditions here on the network. Firstly, can PCB access www.cisco.pka? Again, I'm going to fast forward a little bit there. Again, we're still seeing this error, so we do have a no for that one. And the error is hostname unresolved. That's a DNS-related issue. It's not resolving this or translating it to the correct IP address. So that DNS is not working. What if we try using the web server IP address 209.165.201.2, bypass the DNS? So that is a yes, that is successful. Before we do our documentation part, I want to show you something. If you go to the command prompt, when we did the IP config earlier, that showed us our IP4 addressing information, but not our DNS information. So if you add the /all to that, that's where you can get the list of your DNS servers. So currently the DNS servers for PCB, there's an IP6 one assigned, and the IP4 is the DNS2 server, which is 209.165.201.4. So there appears to be a problem with that server. Is it reachable? Yes, it is. It's responding to pings. But remember, at the beginning of this scenario, it told us some upgrades and changes had been made to this server. It's possible something may have gone wrong there. Now, there is another DNS server on the network that we could try, which is 201.3. Is it pingable? Yes. So what if we were to try going to this desktop configuration here and changing the DNS server from the .4 to the .3 and see if that DNS server is working okay. So once I change that, if I go back to the web server, this time www.cisco.pka, can we resolve that successfully to 209.165.201.2? Yeah. So that DNS server is working okay, and that fixes the problem there with PCB. So in your documentation, where it says document issues and provide solutions, You can say something like, okay, we still have this issue where PCB can access the web server only using the IP address, but not the URL. There appears to be a problem with the DNS2 server because when you tried the DNS1 server, it worked correctly. Now, we don't have control over DNS2 server, so we cannot fix that problem. So we put in a workaround pointing it to the other DNS server. And to get the DNS2 server fixed, you'd have to escalate the issue. The next question is, could all the issues be resolved on PCB and still make use of DNS2? Well, no, because DNS2 appears to be the issue, being able to reach www.cisco.pka. That's not possible with DNS2. So no, there appear to be some configuration problems on DNS2, and you would need to contact the person in charge of that and report your findings to them and ask them to fix it before PCB could be configured again with that as its DNS server. At this point, your document should be all filled in and 100% completion on your PKA file. So just save both. Thank you.